Mathematics Chapter 3 Pair of Linear Equation in Two Variable Standard 10th. Now introduction. First we see what you mean by equation. An equation is a statement that two mathematical expressions having one or more variables are equal. Now linear equation. Equation in which the power of all the variables involved are 1 and called linear equation. The degree of linear equation is always 1. General form of a linear equation in two variables. The general form of a linear equation in two variables is ax plus by plus c equals to 0, where a and b cannot be 0 simultaneously. That means both the terms cannot be 0 at a time. For example, let us substitute x equals to 1, y equals to 1 in the left hand side of the equation. 2x plus 3y equals to 5. So we get LHS equals to 2x plus 3y. Replacing the value of x equals to 1, y equals to 1, we get 2 into 1 plus 3 into 1 equals to 2 plus 3 equals to 5, which is equals to RHS of the equation, that is 5. Now let us take some other value. Let us substitute x equals to 3 and y equals to 2 in equation 2x plus 3y equals to 5. Therefore, LHS equals to 2 into 3 plus 3 into 2, that is 6 plus 6 equals to 12, which is not equals to 5. Therefore, x equals to 3, y equals to 2 is not a solution of the equation. Therefore, solution of linear equation two variable means is a pair of values, one for x and other for y, which makes the two sides of equation equal. Example, if 2x plus y equals to 4, here if we replace x equals to 0, y equals to 4, it is one of its solution as it satisfies the equation. So a linear equation in two variables has infinitely many solutions. Two linear equations in the same two variables are called pair of linear equation in two variables. So we are going to study about the pair of linear equation in two variables. The most general form of a pair of linear equation is a1x plus b1y plus c1 equals to 0, and the other pair is a2x plus b2y plus c2 equals to 0, where a1, a2, b1, b2, c1, c2 are real numbers such that a1 square plus b1 square is different from 0, a2 square plus b2 square is different from 0. A pair of values of variable x and y which satisfy both the equation in the given system of equation is said to be the solution of simultaneous pair of linear equation. A pair of linear equation in two variables can be represented and solved by graphical method and algebraic method. Now representing linear equation for a word problem. To represent a word problem as a linear equation, identify unknown quantities and denote them by variables. Represent the relationship between the quantities in mathematical form, replacing the unknowns with variable. Now let us see an example of exercise 3.1, sum number 3. The cost of 2 kg apple and 1 kg grape on a day was found to be rupees 160. After a month, the cost of 4 kg apple and 2 kg grape is rupees 300. Represent the situation algebraically and geometrically. Let the cost of 1 kg apple be rupees x and cost of 1 kg grapes equals to rupees y. Given that the cost of 2 kg apple and 1 kg apple on the day was found to be 160 rupees. so that 2x plus y equals to 160, our first equation. So we get 2x equals to 160 minus y. So x equals to 160 minus y upon 2. Now let us replace some value of y to get the value of x. Now if you take y equals to 0, we get x equals to 80. And if we take y equals to 80, we get x equals to 40. And if we take x equals to y equals to 160, we get x equals to 0. So replacing the value of y equals to 0, 80 and 160 in the equation x equals to 160 minus y upon 2. Given the cost of 4 kg apple and 2 kg apple is rupees 300. So we get 4x plus 2y equals to 300. That is our second equation. Now 2 is common in this. We get 2x plus y equals to 150. So y equals to 150 minus 2x. Now the first one we have taken x equals to 160 minus y upon 2 is in the x form. Second equation y equals to 150 minus 2x is in the y form. We are taking just to make the equation easy. Now putting x equals to 0, 7, 50 and 75, we get y equals to 150 for x equals to 0. And for x equals to 50, we get y equals to also 50. And for x equals to 75, we get y equals to 0. So the algebraic equation 2x plus y equals to 160, and second one when we are reducing it, we get 2x plus y equals to 150. Now here the variables coefficient of x and y are same. Only the constant term is changing. The above example can be represented geometrically in this form. They will have infinitely many solutions. Now geometrical representation of a linear equation. Geometrically, a linear equation in two variables can be represented as a straight line. The graph of a linear equation in two variables is a straight line. We plot that straight line as follows. Now let us take the geometrical equation, pair of linear equation in two variables. A pair of linear equation in two variables can be represented as a1x plus b1y plus c1 equals to 0, a2x plus b2y plus c2 equals to 0. The coefficient of x and y cannot be 0 simultaneously for an equation. Now nature of two straight line in a plane. Graphical method. The graph of a pair of linear equation in two variable is represented by two lines. For a pair of straight line on a plane, there are three possibilities. The first one, they intersect at exactly one point. That means two lines can intersect exactly one point. Second possibility, they are parallel. That means they are not going to intersect in any of the common point. And third possibility, that they are coincident, that is they are one and the same line. Now condition for this consistency, let the two equation be a1x plus b1y plus c1 equals to 0, a2x plus b2y plus c2 equals to 0. This is our standard equation with a condition that the coefficient of x and y cannot be 0 simultaneously for an equation. Comparing the ratios of coefficient of a linear equation. If a1 upon a2 is not equal to b1 upon b2, the pair of the equation are said to be consistent. Graph of two equations intersect at unique point. The pair of linear equation has exactly one solution. For example, we take two pair of equation x minus 2y equals to 0 and 3x plus 4y minus 20 equals to 0. These are the two pair of equation. Now we find out a1 upon a2 is 1 by 3, b1 upon b2 is minus 2 upon 4, c1 upon c2 is 0 upon minus 20. Comparing this ratio, we get a1 upon a2 is not equal to b1 upon b2. So graphical representation is they are the intersecting line, and algebraic representation means they exactly have one solution, that is they have a unique solution. Now if we take the second condition, if a1 upon a2 equals to b1 upon b2 equals to c1 upon c2, the equation are said to be dependent. One equation can be obtained by multiplying the other equation with a non-zero constant. In this case, graph of both the equation coincide. Dependent equations are consistent. The pair of linear equations have infinitely many solutions. Let us see an example. Pair of equation 2x plus 3y minus 9 equals to 0. 4x plus 6y minus 18 equals to 0. So a1 upon a2 equals to 2 upon 4. b1 upon b2 equals to 3 upon 6 and c1 upon c2 equals to minus 9 upon minus 18. When we take out the ratio, it is 1 by 2 for a1 upon a2, b1 upon b2 or c1 upon c2. So comparing the ratio, we get a1 upon a2 equals to b1 upon b2 equals to c1 upon c2. So graphical representation is they are coincident line. Algebraic representation that they have infinitely many solution. Third condition, if a1 upon a2 equals to b1 upon b2 is not equal to c1 upon c2, the equation are said to be inconsistent. The graph of the equation are parallel to each other. The pair of linear equation have no solution. Let us take an example for that pair of lines as x plus 2y minus 9 equals to 0, 2x plus 4y minus 12 equals to 0. So a1 upon a2 is 1 by 2, b1 upon b2 is 2 by 4, that is also 1 by 2, and c1 upon c2 is minus 4 upon minus 12, that is 1 by 3. Now comparing the ratio, we get a1 upon a2 is equal to b1 upon b2, but that is not equal to c1 upon c2. The graphical representation is a parallel lines, and algebraic representation they have no solution. Now algebraic method. There are following methods for finding the solution of a pair of linear equation. The first one is substitution method, second is elimination method, and the third one is cross multiplication method. There are several situations which can be mathematically represented by two equations that are not linear to start with, but we allow them so that they can reduce to a pair of linear equations. Consistent system. A system of linear equation is said to be consistent if it has at least one solution. Inconsistent system. A system of linear equation is said to be inconsistent if it has no solution. Now the algebraic method one by one we will see in our next video.